Hi everyone, Rao sir here. Welcome to Rao's chemistry classes. In this video, I am going to discuss order of reaction and their units. Actually, previously we have discussed rate of reaction and rate expression. But this video, I am going to confine to order of reaction. It is one of the most important concept in chemical kinetics topic. So listen very properly. What is order of reaction? What are the key points of order of reaction? Let's have a look. Yeah. Order of reaction. What is the order of reaction? The sum of powers of concentration terms. The sum of powers of concentration terms in a rate equation is called order of reaction. The sum of powers of concentration terms. Let us take one equation, alpha A plus beta B. These are reactants. It is a stoichiometry. Alpha beta stoichiometry. So A and B are reactants. Gives rise to product. Yeah. So here, how to write rate expression for this one? How to write rate expression? Rate expression you need to write for reactants only. Yeah, that is the main key point. So rate expression equal to A power alpha, next B power beta. So here alpha plus beta, these are the powers, the sum of powers of concentration terms. Concentration terms is nothing but A concentration, P concentration, and these are the powers. So alpha plus beta equal to order of reaction. Alpha plus beta, the sum of powers of concentration terms of reactants in a rate equation is called order of reaction. So alpha plus beta equal to order of reaction, where alpha equal to order with respect to reactant A, where beta equal to order with respect to reactant B. Clear? Next, main key points. First one, it is a experimental concept. It is a experimental concept. Order may be 0 or positive or negative or fractional. So ultimately what I want to say is, it is an experimental concept. It is not a theoretical concept. It is determined experimentally. So order may be 0, positive or negative or fractional. So next one, it depends upon pressure and temperature. Order of reaction depends upon pressure and temperature. Yeah, बोले तो, so if you change temperature and pressure, maybe order change होने का chance है. Yeah. Next, order of reaction do not have any relationship with stoichiometry of reactants. This is very much important point. Order of reaction do not have any relationship with stoichiometry of reactants. Stoichiometry बोले तो, so here alpha beta stoichiometry. Suppose if I take like this, N2 plus 3H2 gives rise to 2NH3. So what is the stoichiometry of N2? 1. What is the stoichiometry of H2? 3. What is the stoichiometry of NH3? 2. So these are the stoichiometric coefficients. But here you need to notice one point. Order of reaction do not have any relationship with stoichiometric coefficients of reactants. Yeah. Is it clear, my dear students? Next, we will discuss types of order of reaction. Types of order of reaction. Once again, what is order of reaction? The sum of powers of concentration terms in a rate equation. Rate equation, rate law, rate expression. Terminology is different, but meaning is same. Clear na students? Yeah. So order of reaction types. Zero order reaction, first order reaction, second order reaction, third order reaction. Just look at the board. So order of reaction. Zero order reaction, first order reaction, second order reaction, third order reaction. We will discuss one by one clearly. So first, what is zero order reaction? Zero order reaction means rate of reaction does not depend upon any concentration term. Rate of reaction does not depend upon any concentration term of reactant. Yeah. So zero order, A gives rise to product. What will happen? Rate does not depends upon any concentration term. Otherwise, if you take like this, A plus B gives rise to product. A plus B gives rise to product. Here two concentration terms, but rate of reaction does not depends upon time indication. Suppose if you take H2 plus Cl2 gives rise to 2HCl in the presence of sunlight. So here what are the reactants? So H2 plus Cl2 are the reactants and this is the product. So here you need to understand one important point. Here speed of the reaction does not depends upon concentration of H2 and concentration of Cl2. But here depends upon sunlight. Sunlight is a natural procedure. Yeah. So that's the reason you need to write like this. Rate equal to K H2 power 0 and Cl2 power 0. Isn't it? Yeah. So here this is 0 is nothing but zero order reaction. So what is zero order reaction? Rate of reaction does not depends upon any concentration terms of reactant in a rate equation. Is it clear, my dear students? Yeah. Next, what about first order reaction? First order reaction is nothing but rate of reaction, speed of reaction depends upon one concentration term. What about second order reaction? Rate of reaction depends upon two concentration terms. What about third order reaction? Rate of reaction depends upon three concentration terms. Is it clear? Yeah. So just look at the board. First order reaction. A gives rise to product. A gives rise to product. So you can write like this. Rate equal to shortcut R K A power 1. Next, what about second order reaction? We can write like this. 2A gives rise to product. Otherwise, A plus B gives rise to product. P is nothing but product. So for this equation, you can write like this. R equal to K A power 2. For this equation, you can write like this. R equal to A power 1 and B power 1. So 1 plus 1 is nothing but second order. Is it clear, my dear students? Yeah. Next, what about third order reaction? Rate of reaction depends upon three concentration terms. Like 3A gives rise to product. P is nothing but product. Otherwise, you can write like this. 2A plus B gives rise to product. Otherwise, A plus B plus C gives rise to product. These are the possibilities. Clear? So if you want to write rate expression for this one, you can write like this. R equal to K A power 3. Is it clear, my dear students? So, okay students, next, zero order reaction, first order reaction, suitable examples. Very, very important examples. Just have a small look. Zero order reaction. So what is zero order reaction? The rate of reaction does not depend upon any concentration term. So what is the representation of zero order reaction? So let us take A. A gives rise to product. Let's take one example, suitable examples. H2 plus Cl2 in the presence of sunlight to form 2HCl. So already I told you, already I have given this equation. Here rate of reaction does not depend upon concentration of H2 and Cl2, depends upon sunlight. So you can write like this. Rate equal to H2 0, Cl2 0. So next, one more important example, decomposition of ammonia. Ammonia in the presence of sunlight or molybdenum or tungsten, it gives like this, N2 plus 3H2. So here also the decomposition of NH3 depends upon this one only. So you can write like this, rate equal to NH3 power 0. Don't write it 2. Already I told you, rate of reaction does not depend upon stoichiometry of reactant. Yeah. An example, N2O. N2O is nothing but laughing gas. It can convert like this, N2 plus of O2. Clear? Next, decomposition of HI. Decomposition of HI on gold surface. This is also important example. So it can convert into like this. So here rate of reaction does not depend upon this one. Depends upon gold surface. You can write like this, R equal to HI power 0. Is it clear, my dear students? These are the wonderful examples of zero order reaction. Okay students, next, first order reaction. So rate of reaction depends upon one concentration term, that is nothing but first order reaction. So general equation, A gives rise to product. A gives rise to product. So you can write rate expression like this. Yeah. What are the suitable examples? N2O5. Decomposition of N2O5. It can convert into like this. So here rate equal to N2O5. Next, one more suitable example, very, very important example, H2O2. H2O2 is nothing but hydrogen peroxide. So H2O2, it convert like this, H2O plus of O2. Is it clear, dear students? Yeah. Next, one more example. Before that, rate expression. Before that, rate expression. Okay, NH4NO2 we can convert into N2 plus 2H2. So here you can write like this, rate equal to K NH4NO2. Clear? So here power 1 first order, power 1 first order, power 1 first order. Clear? Very simple concept. Just have a small look. Okay students, next second order reaction and third order reaction, suitable examples. So what is second order reaction? Rate of reaction depends upon two concentration terms. Yeah. So what are the suitable examples here? What is the basic skeleton? 2A gives rise to product. Otherwise, A plus B gives rise to product. We can represent like this. So what are the suitable examples? This is the suitable example. 2N2O5 gives rise to 2N2O4 plus O2. So here rate expression equal to K N2O5 2. So what is the power here? 2. That indication second order reaction. Next, and some more examples. 2N2O gives rise to 2N2 plus O2. So rate equal to K N2O power 2. Next, 2HI without any gold surface. So H2 plus I2. So rate equal to KHI power 2. Next example, 2Cl2O gives rise to 2Cl2 plus O2. Same scenario, R equal to K Cl2O power 2. So power 2, power 2, power 2, power 2. That indication, konsa second order reaction. Next, H2 double bond CH2 plus H2 in the presence of nickel. It convert like this, CH3, CH3. So here rate expression depends upon this one and this one. So you can write like this, R equal to K CH2 double bond CH2 and H2. Here 1, 1 plus 1, 2 means second order. So these are the suitable examples. Just have a small look. Rate of reaction depends upon three concentration terms. Clear? So what are the suitable examples? What are the suitable examples? 2NO plus O2 gives rise to 2NO2. Clear? So here rate expression is nothing but rate equal to K NO power 2 and O2. So 2 plus 1, 3. We can write like this, R equal to K NO and Cl2. This is also one of the example. Next, 2FeCl3 plus SnCl2 converts into 2FeCl2 plus SnCl4. Here rate equal to KFeCl3 2 and SnCl2 1. So 2 plus 1 is nothing but 3. So these are the suitable examples of third order reaction. Is it clear, dear students? Just have a look. Negative order reaction, you need to understand this point. When the concentration of reactant increases, rate increases. When the concentration of reactant increases, rate increases. Same scenario. When the concentration of reactant decreases, rate decreases. What are the suitable examples? This is the most important example. Decomposition of ozone. This is ozone. ओजोन डिकम्पोज किया तो आपको ऑक्सीजन आ जाते हैं. सो नेक्स्ट ऑक्सीजन ऐसा भी कन्वर्ट कर सकते हैं. सो हियर विथ रेस्पेक्ट टू ओजोन पॉजिटिव ऑर्डर, विथ रेस्पेक्ट टू O2 नेगेटिव ऑर्डर. सो विथ रेस्पेक्ट टू O2 order is -1. Keep in your mind, very much important example. Next, 2SO2 plus O2 convert into 2SO3 with respect to SO3. So order is negative, -1/2. These two examples are very much important. Being a students, you have to remember. Why? Because it is the experimental concept. So some of the examples you need to by heart. Yeah. Okay students, next, units of order of reaction. Super trick. So suppose examination में आपको क्वेश्चन ऐसा आया, what is the order of nth order reaction? What is the order of nth order reaction? So for nth order, this is the formula. For nth order, this is the formula. Mole power 1 minus n liter n minus 1 second inverse. Clear? You just remember this one. Then automatically you can able to find out any order, any unit order. Yeah. For example, if you want zero order, so zero order means n equal to 0. So you have to substitute n value here. Then mole 1 minus 0 liter 0 minus 1 second inverse. Then it becomes like this. Mole 1 minus 0 is nothing but mole. So liter 0 minus 1 is nothing but liter inverse and second inverse. So what is the unit of zero order reaction? Mole per liter per second. Mole per liter per second. Next, first order reaction. So mole 1 minus 1 liter 1 minus 1 second inverse. That indication 1 minus 1 is nothing but 0. Anything power 0 value is 1. So answer is just second inverse. First order reaction unit is second inverse. Next, what about second order reaction? So mole 1 minus 2 liter 2 minus 1 second inverse. Then it becomes like this. 1 minus 2 is nothing but mole minus 1 liter 1 second inverse. You can write like this also. Liter per mole per second. Clear? Next, third order reaction, n equal to 3. So mole 1 minus 3 liter 3 minus 1 second inverse. Then it becomes like this, mole inverse. Is it clear, my dear students? Yeah. Just look at the board. So what is the super trick? So being a student, you have to remember only one order reaction, one unit. Being a student, you have to remember only unit of one order, that is nth order. This is the nth order. For nth order, the unit is mole power 1 minus n liter power n minus 1 second inverse. That's it. That's enough. ये आदमी रखो, ऑटोमेटिकली आपको मालूम होते. अगर जीरो ऑर्डर पूछे तो n वैल्यू जीरो ले लो, फर्स्ट ऑर्डर पूछे तो 1, सेकंड ऑर्डर पूछे तो 2, थर्ड ऑर्डर पूछे तो 3. सो अभी क्या करते हैं, ये n वैल्यूज जस्ट सब्स्टिट्यूट करो, इसमें सब्स्टिट्यूट करो, आपको यूनिट्स आ जाते. लेट्स टेक जीरो ऑर्डर रिएक्शन, n इक्वल टू 0. सो देन मोल पावर 1 माइनस 0 लीटर पावर 0 माइनस 1 सेकेंड इनवर्स. देन इट बिकम्स लाइक दिस. क्लियर? नेक्स्ट, अगर 1 सब्स्टिट्यूट किया तो आपको ऐसा आते, 2 सब्स्टिट्यूट किया तो आपको इसमें 2 सब्स्टिट्यूट किया तो n प्लेस में ऐसा आते, 3 सब्स्टिट्यूट किया तो n में ऐसा आते. वेरी सिंपल कॉन्सेप्ट स्टूडेंट. क्लियर ना? Okay students, bye for now. See you again. Each and every student, please subscribe my channel and like and share and click the bell button to get further notifications. And bye for now. See you again.